Hello everyone, welcome back to Tales of Chemistry. Today we are discussing Standard 10 Chemistry Metallurgy. In this episode, we will be learning certain terms involved in metallurgy as well as the techniques that we follow for dressing of the ore. Now, first term that we need to study is a mineral. Any naturally occurring compound of the metal, along with the impurities, it can be called a mineral. Naturally occurring compound of metal, along with the impurities, are called minerals. Ore is that mineral from which the metal can be extracted profitably and conveniently. If extraction of the metal is easy and a good amount of metal is collected, then such a mineral can be termed as an ore. The process of extraction of a metal from its ore is called metallurgy. Now, the impurities present in the ore, it can be called matrix or gangue. Matrix or gangue is the term that we give for the impurities. To remove the impurities, we can add or we may add certain substances. Those substances which are added to get rid of the impurity, they are called flux. Flux will react with the gangue or matrix to give molten compound called slag. Let us see some of the common ores of three metals as per syllabus: aluminium, zinc and iron. The common ores of aluminium are bauxite, cryolite and corundum. Bauxite happens to be the main chief ore of aluminium. Its chemical name is hydrated aluminium oxide and the formula is Al2O3.2H2O. Hydrated aluminium oxide, bauxite, which is the chief ore of aluminium. Next ore is cryolite, sodium aluminium fluoride, Na3Al(F6) is the formula. Third ore is corundum, which is aluminium oxide, Al2O3. So, out of these, the possible questions are: name any two ores of aluminium, or which is the chief ore of aluminium. Those kind of questions are possible. Moving on to the ore of zinc. Zinc blende, calamine and zincite are the common ores of zinc. Zinc blende is zinc sulfide, ZnS. Calamine, zinc carbonate, ZnCO3. Zincite, ZnO, zinc oxide. Similarly, last metal that we need to study, iron. There are four ores which we need to remember: hematite, magnetite, iron pyrites, and spathic iron ore. Hematite is iron trioxide. Magnetite is triferric tetroxide or tri-iron tetroxide. Iron pyrites is iron disulfide FeS2. Spathic iron ore is iron 2 carbonate FeCO3. Moving on to the steps involved in metallurgy. First step in metallurgy is dressing of the ore, or in other words, it is just the concentration of the ore. Dressing of the ore or concentration of the ore. There are several methods available for ore dressing. But we need to focus only on three methods: magnetic separation, hydrolytic method of separation, and finally froth flotation technique. Let us see what is this magnetic separation. Here the condition is either the ore or the impurity. Any one has to be magnetic. And let's just look at this diagram. Here, there are two wheels and a conveyor belt moving along the wheels. Out of these two, one of the wheel is a non-magnetic wheel. And right above the non-magnetic wheel, we will be admitting powdered ore. Powdered ore along with the impurities will move along the conveyor belt. Once it reaches the magnetic wheel, all non-magnetic particles get moved away, deviated from the path, and all the magnetic substances can be collected right below the magnetic wheel. So, this can be used when any one, either the ore or the impurity, is magnetic. Fine. So pulverized ore is made to move through the conveyor belt. Magnetic particles are attracted to the magnetic wheel. Non-magnetic particles move away from the wheel. That was the easiest method of ore dressing. Second method that we need to focus on is hydrolytic method. Hydrolytic method can also be called gravity separation. The reason to call it gravity separation is the separation is done due to the difference in the density of the particles. Okay, separation is done based on the density difference. Ore and the impurity, they are not equally denser. Generally, the ore will be heavier or denser than the impurities. Denser ore particles settle in the grooves. Lighter gangue particles, impurity, are washed down. Let's see what is happening in this. There is a vibrating sloping surface. So the sloping part here, that can be made vibrating. From the top part of it, we admit powdered ore. In fact, we wash it down with water. As the ore runs down, washes down with water, all the heavy ore particles get stuck to this gaps or the grooves present, and the lighter impurities are washed down along with water. Lighter particles are getting washed away with water. Heavier ore particles are getting stuck to the grooves present here. All right. So that is about gravity separation or hydrolytic method. The third one is in fact the most important one, froth flotation method. In this method, we are using a selected kind of ore only. That is, this is for sulfide ore. Froth flotation technique is for sulfide ores. Now, the principle involved here is ore and impurities are separated by preferential wetting. The meaning of this term, preferential wetting, is ore is wetted by oil, impurities are wetted by water. Let's see what is the meaning of this. So, in a large tank, you will have to take plenty of water, then put ore particles into it, into water, and a thin layer of oil. So, water, oil, powdered ore. Once this is done, you will be, admitting a hot blast of air. So this air, when you admit, it causes a agitating movement, or it gets the water, oil, and ore mixed properly. As a result, froth will be created. So you get a foam or a froth-like layer on top. Into this froth layer, ore moves on. So ore with oil will be on the top. Water and impurities. Water and impurities are getting settled at the bottom. Impurity being heavy sinks to the bottom. Water remains on top of it. There will be a oil and water layer, and on top of it, you get a froth or a foam-like layer in which oil will be there and your ore particles are there, which can be collected. So the froth can be collected, and then from the froth, ore can be separated. So that is about froth flotation. Generally, questions are asked from froth flotation. Type of question, what is the principle? Principle is preferential wetting. Where do you find the ore? Ore will be found in the froth, and what kind of ores are separated by this method? Sulfide ores are separated by this method. That's all in this episode. Stay tuned for more videos. Thank you.